You're sailing on a calm ocean when you see it, a giant wave rising out of the water, towering over your boat. Uh-oh. But before you can react, the deck suddenly disappears beneath your feet, and you're falling into a deep and vast pit in the sea. Neither outcome gives you a chance to survive. Apparently, the ocean can both crash down on you and suddenly drop away beneath your feet. It's not your day. Well, in the first case, it will be a giant rogue wave. These waves are huge and dangerous ocean waves that appear suddenly and are at least twice as tall as the waves around them. These waves can rise up in the open ocean without warning and may move in a different direction than the wind and other waves. They're extremely dangerous even for big ships because they form super quickly and grow to be exceptionally large. But there's even a scarier threat in the ocean: rogue holes. Those are massive pits in the water, and until recently, no one could confirm their existence. They are the opposite of rogue waves. Instead of a huge wave rising up, they are deep dips in the ocean that appear suddenly, sometimes just before or after a big wave. The water drops sharply, often surrounded by normal-sized waves on either side. When the difference between the top of the waves and the bottom of the dip is much bigger than normal, it can be just as dangerous for ships as a giant 80 to 100-foot wave. Now, scientists have figured out that big waves and deep dips often happen together, so the danger they present now doubles. ESA's Max Wave project was studying rogue waves when they found evidence of rogue holes. After that, researchers even recreated rogue holes in a large water tank to study them safely. And they found out that, apparently, rogue waves and rogue holes come from the same hidden pattern in the ocean. You see, the Max Wave project didn't officially list rogue holes as a separate type of wave, but scientists did notice something unusual in their data. They saw deep drops in the ocean surface appearing together with very large wave peaks. This suggested that rogue holes might exist, but there was not enough evidence to confirm it. To test this idea, a team of researchers at Kyoto University recreated ocean-like waves in a long wave tank, about 50 feet long. It worked like a controlled mini-ocean where scientists could carefully adjust wave size and speed. Inside this tank, they were able to create both giant rogue waves and deep rogue holes. The rogue holes looked like sudden voids in the water, deep dips surrounded by normal-sized waves, like the ocean briefly sank down in one spot. It's similar to a sudden pothole appearing on the road, but filled with moving water instead of asphalt. So imagine normal waves as fast repeating bumps moving across the water. Now imagine a much slower, bigger wave on top of that. It looks like a rolling hill that lifts everything up and down. This bigger wave controls how strong the smaller waves are. If the hill hits a wave right when it's already at its highest point, the wave grows into a huge rogue wave, as if someone stacked one wave on top of another. But if that same hill pushes down when a wave is at its lowest point, it creates a deep hole in the water instead. It's like the ocean suddenly drops beneath your feet. So it's the same process, just timed differently. At times, it creates a giant wall of water, and at other times, it's a sudden dangerous drop. So the results of the experiment matched the mathematical predictions. They proved that those strange wave patterns were not just a theory, but something that can really happen in the ocean. In 2016, scientists compared mathematical models with real ocean measurements and found patterns that match both giant waves and deep holes in nature. Of course, in the real ocean, these shapes are not perfectly smooth like in experiments. The waves often have sharper, uneven edges, like a hill that is steeper on one side than the other. But even with these differences, they still followed the same hidden structure. This confirms that rogue waves and rogue holes are really two kinds of the same ocean event. They're just shaped differently by timing and energy. Meanwhile, we still really don't know the ocean. Most of it is a mystery to us. Less than 1/1000th of the seafloor has been seen up close. Imagine the size of Rhode Island or Luxembourg, hey, pick one. That tiny bit is what we have mapped. Everything else, deep trenches, cracks, caves, massive underwater mountains, remain blurry on our maps. Many phenomena went unexplained for centuries, too. For example, sailors kept reporting enormous waves that suddenly towered over everything else, sometimes more than twice the height of normal waves. Back then, most people thought these reports were exaggerations, like spotting mermaids or a giant squid. But those waves were real. Now, in 1826, Dumont d'Urville, a French naval officer and explorer, sailed the Indian Ocean on the ship Astrolabe. Yeah, it's a bad French accent. He saw waves of at least 80 to 100 feet tall during a violent storm that took the life of a crew member. At that time, scientists thought waves couldn't exceed about 30 feet. So, even though his account sounded unbelievable, D'Urville insisted on recording it. And guess what? Yup, instead of being praised, he was laughed at. Okay, I'll stop. Now, even earlier, in August 1498, during his third voyage to the Americas, Christopher Columbus and his crew heard an enormous roar from the sea and saw a wave rising behind their ships. It was as tall as the masts. The wave lifted the ships higher than anything they had ever experienced, and then dropped them into a massive trough. It was like a roller coaster made of water. Now, modern oceanography has confirmed that such colossal waves do exist. They're like skyscrapers suddenly appearing in the middle of a calm sea. A normal wave might be tall enough to reach the roof of a 2-story house, but a rogue wave can tower like a 10-story building. In 1861, such a wave apparently smashed a lighthouse in Ireland. It shattered lamps and sent debris tumbling down a lighthouse staircase. To do that, the water had to climb a 130-foot cliff and then an additional 85 feet of the lighthouse structure. It's almost as tall as a 20-story building. Rogue waves appear suddenly, often without warning, in the middle of the ocean. These waves form when winds, currents, and smaller waves line up just right, making a single giant wave much taller than the others around it. They aren't tsunamis and aren't caused by earthquakes or volcanoes. Physicists model this using something called the nonlinear Schrödinger equation, but basically, it just explains how the ocean can suddenly make a giant wall of water. On January 1, 1995, the Dropner wave struck an offshore gas platform in the North Sea off Norway. It measured 84 feet. This was the first time a rogue wave was officially recorded, proving those monster waves were real. But scientists still consider them rare. Well, by the year 2000, the European Space Agency's Max Wave project confirmed that rogue waves were more common than anyone thought. Using radar from ESA satellites, scientists studied the global ocean and found many waves exceeding 82 feet. Some of the largest recorded waves even reached 98 feet near Newfoundland. Suddenly, what people used to brush off as sailor stories turned out to be terrifyingly real. On the 17th of November 2020, a weather buoy near Vancouver Island, Canada, recorded a very unusual wave in the Pacific Ocean. The wave reached about 58 feet, while the surrounding waves were only about 20 feet. This made it much larger than normal waves around it. On the 29th of November 2022, a rogue wave hit the cruise ship Viking Polaris near Antarctica. One person lost their life, several others were hurt, and the trip was canceled. On the 18th of September 2023, a large wave hit a beach restaurant in South Africa. 7 people were injured, and one person was swept out to sea but luckily rescued. And on the 20th of January 2024, powerful waves hit a U.S. military site in the Marshall Islands. Buildings were damaged, some areas were flooded, and waves moved far inland, showing how destructive these events can be.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Mantle cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine. See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer, but be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people, and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown of thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate, When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature, and this is another equally important reason why we should stay away from them.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, Check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space, too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!
A wanderer, walking through a desert, feels the scorching sun like never before. You can see him from afar thanks to his shining clothes. His long hoodie is covered with foil. It reflects sunlight and protects him from heat. The ground is so hot that shoe soles can melt on it. That's why the wanderer's boots are covered with heat-resistant material. A cloudless sky, barren land, and heat. But the wanderer is not in the desert. He's walking on the ocean's bottom. He doesn't know why this happened, but all the oceans on Earth dried up. It happened almost instantly, and even the greatest minds in the world don't know why. The wanderer knows only one thing. When it happened, his family was on the other side of the ocean. For several months, he's been traveling across this lifeless land, and he won't stop until he finds his family. The landscape around is spectacular. People have finally found out the secrets of the ocean depths. The seabed consists of huge mountain ranges and volcanoes. They fell asleep forever after the water had disappeared. Also, there are huge trenches leading to the unexplored depths of the planet. People had to build bridges to get over these enormous cracks in the ground. But most of the ocean floor is flat plains, boundless, lifeless, merciless. The wanderer's walking across a huge canyon. Once, it was swarming with sea life. The man puts on a gas mask, but not because of a sandstorm. Many fish and other marine inhabitants used to live in such canyons. Now, all that's left is a terrible smell. The wanderer passes by huge skeletons of whales. Among them, he notices dirty tents. People are hiding there from heat. The temperature in the area is much higher than in the Sahara Desert. One of the main functions of the ocean was to distribute heat all over the planet. The sun emits heat and radiation. The ocean absorbed this energy. Lots of currents were warm, and they carried this warmth around the world. The water got heated at the equator, then it evaporated and turned into clouds. When warm air rose, it pulled along colder air from below. This allowed the energy to be evenly distributed. In simple words, the ocean cooled hot places and brought warmth to cold ones. Now there's none of this. Every day the sun burns the equator and dries up the rest of the planet. The wanderer doesn't come close to the tents. He is carrying the most valuable treasure in the world and doesn't want people to notice him. The inhabitants of Earth are just trying to survive, and many have forgotten about such a thing as morality. Fortunately, the wanderer still remembers. The thoughts of the family help him remain a good person. Sometimes it complicates his life. Like now, for example. In the distance, he sees a young girl. She doesn't look well. There's no one around, and the wanderer decides to help her. Out of his backpack, he pulls a thing worth more than all the gold on the planet, a bottle of water. The girl takes a few sips, but instead of thanking the wanderer, she starts screaming. It's a trap. Her accomplices appear from different sides. Looters. They're gonna take everything. The wanderer runs away. He hasn't eaten for several days, and his strength is leaving him. He won't be able to keep going much longer. The marauders are closing in on him. The wanderer throws the bottle aside. His pursuers rush to the water like crazy. They forget about the man and fight one another for the bottle. The chances of the wanderer's survival have greatly decreased. He could make this bottle last at least several days. Plus, he's also lost a lot of fluid because of running. In the beginning, there was no panic because of a lack of water. The ocean dried up, but its waters were salty anyway. People still had seas, lakes, and rivers. But the problem was that the ocean was feeding them. When the ocean water evaporated, it formed clouds. These clouds moved all over the world and enriched lakes and rivers with rain. Now, there are almost no clouds. The sun started heating Earth much more. Lakes and seas dried up alarmingly quickly. At that moment, real chaos began. The sun is going down on the horizon. Sunset is near. It's not so hot anymore. The exhausted wanderer continues walking. In the distance, he notices something that makes him stop, take out a small shovel, and start digging quickly. There's no shelter around, just a flat plain. The wanderer speeds up, otherwise it might be too late. The pit is finally ready. The man jumps down and covers his head with a cloak. A few seconds later, a strong ash storm passes through the entire plain. The smallest particles of ash can penetrate through clothes and get into the lungs. The wind is so strong that it can knock anyone down. When the oceans dried up, the sun began to burn the surface of the planet. This led to massive forest fires. The flames destroyed almost all the trees. Huge clouds of carbon dioxide and ash formed. Driven by the wind, they travel the world and poison everything around. The wanderer is sitting in the pit while a terrible hurricane is sweeping over his head. He thinks of his family and slowly falls asleep. Cold wakes him up. Frosty air chills him to the bone. So it's night now. The wanderer climbs out of the pit and finds himself under bright stars. As soon as the water dried up, almost all clouds disappeared. Factories stopped working. Cars no longer emitted carbon dioxide. Thanks to this, comets and the most distant stars can be seen in the sky. The wanderer has seen them 1,000 times, but he's still not used to the breathtaking picture. It's like he's looking at the sky through a telescope. An icy gust of wind brings the wanderer back to reality. He won't survive the night if he doesn't find a warmer place. Before, nights were warmer thanks to the energy of the ocean. Now, as soon as the sun goes down, temperatures drop dramatically. The wanderer needs to move to stay warm. He starts walking faster. Soon, he notices some lights in the distance. It's probably other looters. The wanderer goes deeper into the valley. Stars and the moon illuminate his way. Unfortunately, he is running out of energy. He pulls a protein bar out of his pocket, but he needs at least a bit of water to eat it. To digest food, your body needs liquid. If the wanderer eats the bar, he'll only get thirstier. He can't walk and falls to the ground. He checks his pockets and finds a small kerosene tablet. He lights it using a matchstick. A tiny flame protects him from cold. To distract himself from thirst, the wanderer takes out an old MP3 player. He charged it during the day using the solar panels on his backpack. The man puts on headphones. Classical music calms him down. He lies on the ground next to the burning tablet. He needs to gain strength to continue his journey tomorrow. It's morning. In an hour, the sun will start burning the ground again. It's crucial to find water while he still has some time left. The wanderer inspects the territory and notices a spot where the ground is darker. In his previous life, the wanderer worked as a surveyor. He takes a few steps and touches the ground. It feels cool. There's an underground spring here. He begins to dig. The ground is getting wet. Water starts seeping out of the soil. The wanderer fills his empty bottles. Things don't look that bad anymore. It's getting a bit more difficult to breathe with each new day. In the past, phytoplankton and algae produced up to 70% of all the oxygen on the planet, but not anymore. Several days have passed. The wanderer runs out of water and food again. Fortunately, not for long. He's now walking among huge sunken ships. He sees modern aircraft carriers, liners, and even ancient pirate boats. In the distance, he spots huge mountains. The tops of these rocks are what used to be called the shore. The ocean floor is ending. The thoughts about reuniting with his family give him more strength. The man reaches the top and finds himself in the middle of a ruined city. It's empty. Where have all the people gone? Where is my family now? The wanderer asks himself. The man walks through the abandoned streets and meets an old man. He says that almost all the people who used to live here left the city and went to Antarctica. The wanderer has a new goal. He's going to get to the icy mainland no matter what. He will find his family.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, But researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the Mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle megafloods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, The other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, In 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?